All right, guys, so today we're going to talk about geometric probability. Before we do that, we need to talk about what that actually is. So, geometric probability, sorry, I don't know why that's still there. Geometric probability is literally like you're given an area of something, you want to find the probability that whatever event it's talking about is going to be true. And what we're going to do is we're going to take the area of the part and divide it by the area of the whole. So, let's look at the first example. He says, you're sure you can hit a circle, on a target with an exploding watermelon being squeezed by rubber bands. So you set up a square target right in the line of fire with a circle in the center. The square is 5 foot long and 5 foot wide, and the circle has a radius of 2 foot. What is the geometric probability of some watermelon landing in the circle? All right, so we've got a square with a circle in the middle. Okay. And in this, we have a square. The square is 5 feet by 5 feet. And the circle has a radius of 2. All right. So what we're going to do, the area of the part is the area of the circle. We're going to divide that by the area of the whole, which is the square. All right, so I don't know why my 2 went there. So the area of the part, so it's area of circle divided by area of square. Okay, so the area of the circle, area of the circle is pi r squared, so pi times 2 squared divided by the area of the square, and the square is 5 times 5. Okay, so we're going to find that out, and I'm going to type this in just like this on my calculator with a fraction. Alpha y equals enter. Okay, so pi 2 squared over 5 times 5. Okay, so my probability is 0.503 or 50.3%. It's pretty good. It's okay odds, I guess. Okay, that's how geometric probability works. Let's do another one. A game is programmed to randomly put your character somewhere on the computer screen that has a rectangular lava pit on it. If you land in the lava pit, you lose points. The screen is 10 inches by 17 inches, and the lava pit is 2 inches by 10 inches. What is the geometric probability that you'll land in lava? So we've got a computer screen. We've got a little strip of lava. I don't know what in the world that's doing. Doesn't matter if it's perfect. Okay. The screen is 10 by 17. The pit is 2 by 10. So again, it's the part divided by a whole. So the area of the lava is 2 times 10 divided by the area of the hole is 10 times 17. Okay, so 2 times 10 over 10 times 17. 2 over 17, I definitely don't need that. So we're going to press math, enter. Or sorry, not that. 2 divided by 17. Okay, so we have 0.118 or 11.8%. It's a good idea to pause the video, try example 3 on your own, and then see how you did on it, okay? All right, a spit wad machine makes and fires spit wads in a random pattern. It's kind of gross, actually. What is the probability that a spit wad will hit a 2 by 2 foot tile in a ceiling of 50 identical tiles? So the area of the part is going to be our 2 by 2, okay? And our hole is going to be the fact that there are 50 of those, okay? So the area of just one of these is 4 foot squared, okay? But if we have 50 of them, which is the whole thing, so times 50, 4 times 50 is 200. That's the area of the hole. So this one, we already have our numbers. So 4 divided by 200, we get 0.02 or 2%. Okay, so you have a 2% probability of hitting a specific tile. Okay, I did need to show you, in case you have forgotten, to find percentages, you move the decimal place over 2 places, and I should have said that a second ago. That's where all these are coming from. Okay, but there are your answers. Glue this in on the appropriate page. That is how you find geometric probability.